The human brain is a complex web of nerves, each with its own unique function. Among these, the trigeminal nerve stands out as a true workhorse. It's the largest of the 12 cranial nerves, responsible for sensation in the face and motor functions like biting and chewing. Imagine feeling a gentle breeze on your cheek or savoring the taste of your favorite meal. These experiences are all thanks to the trigeminal nerve. The trigeminal nerve isn't just one entity. It's divided into three branches, the ophthalmic, maxillary, and mandibular nerves. These branches work together to provide us with a rich tapestry of sensory input from the face. They also control the powerful muscles we use for chewing, making the trigeminal nerve essential for everyday life. But the story of the trigeminal nerve goes deeper than these three branches. At its core lie four nuclei, clusters of nerve cells that act as processing centers for sensory information and motor commands. These nuclei, the mesencephalic, main sensory, spinal, and motor nuclei, are essential for the trigeminal nerve to carry out its diverse functions. In the following sections, we'll delve into the fascinating world of these nuclei, exploring their roles in proprioception, touch, pain, temperature, and motor control. We'll also uncover the clinical significance of the trigeminal nerve, examining conditions like trigeminal neuralgia, and the implications of procedures like the inferior alveolar nerve block. Understanding the intricacies of this mighty nerve is crucial for medical professionals and anyone curious about the workings of the human body. Imagine taking a bite of an apple. You feel the crunch of the fruit, the sweetness on your tongue, but there's another sensation at play here, proprioception. This sense, often called our sixth sense, allows us to perceive the position and movement of our body parts without relying on sight. In the context of biting an apple, proprioception tells us how wide to open our mouth, how hard to bite down, and where our jaw is in space. The mesencephalic nucleus, nestled deep within the brain stem, plays a crucial role in this unconscious awareness of our jaw muscles. Unlike other sensory nuclei that receive information from external stimuli, the mesencephalic nucleus gathers input from within, specifically from muscle spindles in the muscles of mastication. These spindles act like tiny sensors, detecting changes in muscle length and tension. When you bite down, the muscle spindles in your masseter and temporalis muscles, responsible for closing the jaw, are stretched. This stretching triggers signals that travel along the trigeminal nerve to the mesencephalic nucleus. The nucleus then relays this information to other parts of the brain, providing a constant update on the position and tension of your jaw muscles. This feedback loop is essential for coordinating smooth, controlled movements of the jaw. It allows us to adjust our bite force depending on the food we're eating, preventing us from biting down too hard or too softly. The mesencephalic nucleus therefore acts as a silent conductor, orchestrating the symphony of muscle movements that make chewing possible. The world is a cacophony of textures, temperatures, and pressures, and our sense of touch allows us to navigate this sensory landscape. When it comes to the face, the main sensory nucleus of the trigeminal nerve serves as the primary processing center for tactile information. This nucleus, located in the pons, receives input from the ophthalmic, maxillary, and mandibular branches of the trigeminal nerve. These branches carry signals from specialized receptors in the skin, mucous membranes, and teeth, each tuned to detect specific types of touch. For instance, Meissner's corpuscles, found in the superficial layers of the skin, are particularly sensitive to light touch and vibrations. They allow us to feel the delicate brush of a feather or the subtle vibrations of a tuning fork. Pacinian corpuscles, located deeper in the skin, respond to deep pressure and high-frequency vibrations. These receptors come into play when we feel the firmness of a handshake or the rumble of a passing truck. In the realm of dentistry, specialized receptors called periodontal mechanoreceptors, located in the ligaments surrounding our teeth, provide feedback on bite force and pressure distribution. Information from all these receptors converges on the main sensory nucleus, where it's sorted and processed. The nucleus then relays these signals to higher brain centers, allowing us to perceive the location, intensity, and quality of touch sensations from the face. This intricate processing pathway highlights the crucial role of the main sensory nucleus in our tactile experiences.